Hi, everyone. Good morning. My name is Ben, as mentioned. Welcome to today's conference talk. And in this session, I will talk about how to speed up deep learning jobs in the cloud using TensorFlow, using the stack of TensorFlow, Alluxio, and Kubernetes. And this is a collaboration work between Alluxio and Alibaba. So we spent quite a few months previously to work on this stack and get a pretty good result. This is the agenda today. And first, I will just outline who this is the agenda. I will do an introduction briefly on myself, and then introduce you the background, why we choose this stack to speed up deep learning, and why this is the important thing to do. And then I will dive deeper in the details of how Alluxio accelerates these AI workloads in the cloud. Finally, we will share some supplementary material that could come handy for you to experience your own using your own environment for experiments. So I'm one of the founding engineers and VP of open source in Alluxio. Prior to Alluxio, I worked in Google to build the next generation storage infrastructure. I received my PhD in computer science from Carnegie Mellon University in designing and implementing distributed systems and network systems. So let's go to the topic today. Why? Everyone is talking about AI. Everyone is talking about deep learning. Why this is the case today? Well, to my perspective, artificial intelligence is one of the very popular area these years and driven by a few factors, including the hardware improvement, such as the GPU produced by NVIDIA. You notice that recently, they just announced a new generation of GPUs. And the software and machine learning frameworks such as TensorFlow and PyTorch are getting mature. So with all the efforts from the open source community and all these companies behind these projects, more people and just ordinary people, they are able to do deep learning jobs without knowing how to program, how to really run this very sophisticated tasks on the hardware, specialized hardware. So it's becoming simpler and simpler for ordinary users. Third, the large amount of data that is available today. So if you notice, for a lot of companies, they are just able to collect a lot of data from their daily operation. And this can be very useful for them to further drive insights or to help optimize the operation. And third, on top of this, we also see a new trend in containerization, such as Kubernetes and Docker, are also becoming very popular choice among the data scientists. There are two main reasons that may help this popularity of the containerization. It provides the standardization and also provides the scalability. For example, both TensorFlow and PyTorch will include the containerized version in their new releases, and people usually just try out this Docker version first. It's very easy to use, very easy to deploy. Because of this standardization of containers, the cluster scheduling based on Kubernetes also makes it very easy to achieve a very large scale distributed training. And you can see nowadays, a lot of people are running training jobs across 16 machines or 32 machines. And I have seen users running over 500 machines for super, super large training jobs. Okay, to summarize this page, we have seen all different things merging together to drive the popularity of the hardware for the artificial intelligence, including the hardware, the software change, the data, and also the standardization in infrastructure. Okay, let's take a look at this slide. It shows you the model training speed for ResNet 50 and in turn measured by the images per second using different models of the GPU cards. And this diagram shows you a few things. We can get two observations. First, the GPU hardware upgrades significantly to increase this training speed. In terms of the computation ability of a single card, the older model like a P100 can process about 300 images per second using this is one GPU. And if you go to 32 GPUs, it goes to 7,300 images per second. So that means the training jobs increase at a scale. If you use one GPU versus 32 GPU, you can see definitely a big jump. Another thing is the GPU upgrades, the model itself upgrades significantly. If you just both compare the P100 using 32 GPUs and the result using V100, which is much, much newer using 32 GPUs, the performance is much, much better. So it's increased by at least 4 times. So these are the two conclusions. That hardware is providing a tremendous amount of new computation power by scaling the hardware itself and by upgrading the hardware itself. Let's see the next slide. So in terms of the training time, in the same date, using the same data, the training goal and also the similar input, a single card P100 requires 100 hours, more than 100 hours, which is about 4.5 days. Whereas V100 distributed 32 cards GPU training requires only 1 hour. This is a significant improvement. So we notice that upgrading GPU hardware not only increases efficiency, but it also saves costs, because if you try this, if you have done this in the cloud, you will notice it's super expensive in the cloud to get these GPU machines. It's very, very expensive. By the way, all this computation only takes into the computation time. The training only takes into computation time, not adding the data loading time, because this is using synthetic data, meaning there's no real I/O. And in reality, if you're training over a big data set, it will also cost you a lot of time. So you can see the computation cost translated into dollar value, and there's a significant difference. So this is exactly very interesting to see. This is exactly what the NVIDIA's CEO, Jensen Huang, says. The more you buy, the more you save, because you are improving the efficiency. Okay, next slide. We can see here, because we had an assumption that there is no real model data I/O, no real data is read or write. So that's really the ideal time, like GPU is fully utilized. But in reality, you always need a massive scale of data to train your models. So that means you have the high computing power requires better I/O performance to match this high computing power. But also the challenge is nowadays the compute and storage are disaggregated in the cloud. Typically, you set up the machines using certain bare metal, you run these bare metals from the cloud. But the data, either you put it in your own storage service or it's in the cloud provided storage, and that can be a distance between them. It's not directly, it's not like co-located to each other. It's not coupled. So that's the typical architecture to do this. And the single machine's RAM typically does not meet the needs for data access speed. You don't have that amount of RAM. That's a luxury to move all your training data into the GPU machines. Well, some people can do that if they're dealing with the tiny or medium-sized data inputs, but oftentimes this is not realistic, this is not practical. And also it's a lot of overhead moving data around. So this creates a lot of challenges in data access. And we realize in this case, there is very significant importance to have a distributed caching on top of in the Kubernetes environment. So you don't have to worry about, oh, do I need to move my data? How do I match my I/O performance to my computing power? So in the AI big data high concurrency scenario, the scalability, the stability, performance, and the resource consumption all need to be considered into this architecture. But all the scenario of compute and storage, there's natural decline in the performance. That's why we need to consider a memory speed distributed caching layer for running this in the cloud. So that's why I want to introduce Alluxio, which is the project I'm working on. It's a data orchestration platform for advanced analytics and AI on the data in the hybrid multi-cloud environment. It was a research project incubated from UC Berkeley AMP lab by the founder and CEO Haoyuan Li when he was making his PhD, doing his PhD work, and he built the beginning of the Alluxio. And we are backed by the top VCs, including Andreessen Horowitz, which is very famous today. And the company was founded, our company is founded and started in 2015. So what is Alluxio? As I mentioned, it's a data orchestration system for the cloud, open source data orchestration for the cloud. It's adding actually a new layer in the data stack. On its top, you can run your analytics frameworks like Spark or Hadoop, MapReduce or Presto, or you can run your deep learning frameworks like a PyTorch or TensorFlow. They may prefer different API, but that's fine. We provide different APIs to different frameworks. On the top to the bottom, you can see we provide different drivers to connect to different storage. So if you're running on AWS, we have the S3 driver. You can connect your data, you can bridge your S3 data into TensorFlow using Alluxio. Or if you have data on your on-premise data cloud, like on-premise cloud storage, like Hadoop, that's fine too. We have the HDFS driver. So it's a bridge between these two. The core features we're providing here is first, it's a distributed caching layer. You can see from here, the data, assume the data is in the object store, and we have two different files. And these files will be chunked into smaller units like blocks. And these blocks can be spread into different Alluxio servers, serving different like big data workloads or model training workloads. So by having this data cached and distributed on multiple nodes closer to the computation, you can definitely increase the bandwidth to serve this model training work. And the next slide shows you the flexible APIs we're providing. So essentially, the second use case is you have multiple different use cases for Alluxio, like you can cache the same data or a different set of data for both machine learning workloads, model training, using the POSIX API we're providing, or to the big data workloads you're running ad hoc query or ETL using Spark, that's fine. Like we provide the same data abstraction and caching with different APIs to different applications in their favorite. The third use case is to unify different storage, external storage into a single namespace. If you have data sources from different places, S3, HDFS, you can just simply mount these external storage into Alluxio namespace. Making them look like they are just different directories in this logical namespace. So the applications and users, they do not need to know whether I'm reading from S3 or I'm reading from HDFS or I'm reading from somewhere else. As long as they know this is a logical Alluxio file address and I'm training data on this logical file address, that's fine. And we will be able to configure the correct library version, using the right protocol, using the right configuration in credentials. So the user becomes really, really easy as long as the system is correctly configured. Okay, now let's go back to the model training, the AI training. So why we want to even deploy this in the cloud for AI training? Well, it will support hyperscale workloads because now you can read data close with much, much higher throughput. As I'm showing here, if you're achieving some good scenario, which called short circuit scenario, the training pod in Kubernetes can get about 1 to 6 gigabytes per second of data, which is super, super fast. Even you are slightly unlucky, the data is not cached on your local pod, local host. That's the case of the worker remote. and you still get about 1 to 2 gigabytes per second using network. So it's still fast. However, if you're reading, this is cache miss, if you're reading from the remote object store through Fuse, we see about like 300 megabytes per second. So it's really depending on the cache hit ratio and how close you are. But like in the ideal case, you can get very high bandwidth to read data to make sure you can get really, really good use of your GPU time to reduce your cost and improve the efficiency. So this is what we see a lot, how people are deploying Alluxio with Kubernetes and TensorFlow. So you run in the same host machine, the Alluxio pod with running Alluxio Worker or Alluxio Fuse pod. But also on the same host, you can run TensorFlow pod or MXNet pod or Cafe pod, and using Alluxio to bridge your training jobs to your storage. And this can serve as a distributed caching layer to help you. You don't need to worry about how to get this data as long as you set these properties. And we recommend you to use something called Helm chart. This is an easy way to deploy. It's very popular nowadays in Kubernetes world, especially for machine learning. And it's very easy to deploy something in the Kubernetes. It's a high-level language. It's a wrapper on top of a Kubernetes deployment. So you can install a service and remove a service easily using a command like something like this. It's very easy to use. Okay, seems like I'm talking about all the good things, but in reality, when we are trying these AI training workloads, we are taught a lesson like easily. So this shows you using V100, a single node V100 GPU for ResNet 50, and it's measured by images per second. So we can see on the y-axis is the image per second, which is the throughput. On the x-axis, it is measured by the number of GPU cards we're using. Well, the problem is, in the beginning, if you're just using one card, on the x-axis is number of nodes. So on the number of GPUs, yeah, on a single node. On the y-axis, on the one single GPU, you see the performance is very similar. It's very similar, very close. But when we increase the number of GPUs to 2 or 4 to 8, so the performance compared to the synthetic case, which is no I/O involved, shown in the blue curve, shows that it's scaling really good. But with the real data kicks in with Alluxio, the scalability is not that good. Actually, if we increase from 4 to 8, the performance is even worse. It's not adding more GPUs after 4 GPUs. It's not helping at all. We see a much less aggregated images per second. The aggregated throughput is much less. Why is that? We did some analysis together with Alibaba engineers on this open source collaboration. So we realized the stack is pretty complicated. We have TensorFlow in this picture. We have Fuse, which is translating Alluxio protocol into POSIX protocol, so TensorFlow can read. We have JNR Fuse, which is a third-party library. We have Alluxio, which is the product produced by our company. And also the kernel is another part. It's a Linux kernel. There's a lot of complication inside. And so this is a huge stack, and there's a lot of complication, including how do we handle the file system metadata, and how do we what's the overhead introduced by Fuse, and if we're reading from remote, there are some RPC costs associated. And we were running Docker with Java. There's also a lot of complication inside. And the threading model, the Fuse and kernel they may use different or not optimized way to coordinate in terms of threading model. In this case, we're having a massive amount of concurrency here. So adding all this together, so we realize it's not something, at least at that time, it's not something you can take it out of the box to make it perform well. Okay, so we decided to do more optimizations. The first thing is to reduce the RPCs. RPC is called remote procedure call. It's a way for in a distributed file system, in a distributed system land, RPC is the most common way for different components in this distributed system to coordinate, to communicate. So for example, in this case, when TensorFlow is reading a file, because it's eventually reading from Alluxio, there will be a Alluxio client talking to a Alluxio master, which is Alluxio metadata service, for list the file status and return this, and get a status for a file, open the file handle, read the file. So all these are translated into the RPCs, which can be very costly in the model training case. So in this case, we decided to cache a lot of metadata on the client side, close or on the same machine as TensorFlow nodes to reduce this cost. This is the first thing we do. And the second thing is we realize there's a lot of things, a lot of configuration in Alluxio land, which is not optimized for the workloads of deep learning, including how do we read data when the data is not cached currently, including how do we set the cache, like a cache space in the Alluxio worker pod, like how many tiers, what's the policy to retire tiers, including how do we do the eviction and how do we do the cache. So all this adding together, there's we previously were more optimizing these parameters for ad hoc queries, like ad hoc SQL queries, not for machine learning workloads. They are very different in the way of the concurrency and in the way the granularity they're reading, and in the way the data set is consistent. Like for ad hoc queries, SQL queries, typically they're reading bigger files with smaller number of files. But with a deep learning case, we often see like people are doing ImageNet, there's a massive amount of small files. So all this is not optimized. So we need to change this behavior too. We need to prioritize the local cache, and we need to avoid frequent data eviction. And we also need to reduce the data redundancy. Adding all this together, that's the principle for us to optimize for deep learning workloads. Next, Fuse is the third-party library we use very often to translate some data service to a local file system module in Linux. That's very, very commonly used. And we realized like even the Fuse, there's a lot of room to improve. Fuse is so commonly used, but it's less well understood in the deep learning case, like what are the parameters we need to tune. So it turns out there's a lot of things we need to patch Fuse to increase background threads. And we need to we upgraded Linux kernel, and we see a much better performance after upgrading the Linux kernel. Newer kernel has better support for Fuse. And we also set some parameters like the max background and max read. One thing we found is very interesting is Fuse is always reading in a very small granularity. It's at a unit of 128 kilobytes. So if you're reading, say, ImageNet, you're reading 1 megabytes per image. That means you need to translate to 8 Fuse calls, and that can be very expensive. So how do we leverage that? And turns out we turned on the buffer cache to reduce the overhead, the kernel to user space translation. So that turns out very helpful too. And we have also done a lot of end-to-end optimization, the Linux kernel JVM optimization in GC policy and optimization in Alluxio metadata. Adding all this together, it's a full stack optimization for workloads in deep learning jobs. And this is what we get in the end. As you can see, the blue curve shows you the synthetic case, which is the best case. You will not able to achieve this at all. This is the theoretical upper bound. And the gray curve is what we can achieve with Alluxio, mostly like caching from the local host, pods on the local host. And so all this adding together, we can the orange curve downside in the bottom is really reading from a remote SSD using network to connect. So as you can see, Alluxio provides much better, like more than 2x performance than the remote SSD on the shown in the green curve, and getting very close to theoretical limit. So that concludes my talk. So basically, you can see there's a lot of things to do to make your deep learning in the cloud work well. And we applied this. This work takes us several months to complete. We examined the whole stack to get all the knowledge, and we learned a lot, and we also optimized a lot. And turns out the result is pretty satisfactory. And this is the result from a month or a few months back, and we'll keep improving this. Actually, we're even improve the performance and also in the deployment side together with engineers at Alibaba. This is open source collaboration. If anyone is interested, feel free to talk to me, and I'm happy to provide more instructions. That concludes my talk.
Thank you, Bing, for the great sharing. We do have questions for you, but mainly for the conference. Like they pretty like your sharing and would like to access your slides and recording of the presentation. Do you mind?
Yeah, of course. I will send you an updated version of my deck.
Okay, thank you. Any other questions?
All right. I think like if no.
I mean, this is
yeah. Hey, Jason.
Yeah. Thank you to be our speaker again. We have been working with Alluxio since our first conference. So I would like to introduce a little bit about the community. I think a lot of our members, we are young professional who working in AI data science industry. So I know you have a PhD degree in engineering, and then you have been working in big data industry for many years. So can you give some suggestion to the young professionals, for instance, the graduate students, or who has been working for 1 or 2 years? So how we can get into the big data industry? So currently data scientists, big data engineers, system design engineers, even consultant, there are a lot of job opportunities. So do you have any suggestion how the young professionals can learn some technology and get some job in this industry?
Yeah, that's a good question. Actually, I was asked pretty, I would say like pretty frequently about something like that, like to how to get some career advice, how to enter this sector. I would say like we're in a very exciting age right now, because the technology is evolving very fast. We are in a very exciting era that there's a lot of things happening. And I don't see it's slowing down. Actually, it's accelerating. The speed of the technology evolution is even speeding up. If you take a look at the big data technology a few years back, maybe a couple 10 years back, at that time in the mainstream, people are talking about Hadoop. That's pretty much what people are doing if you're dealing with big data. But now there are just so many different things. Like each Hadoop is still there and it's still widely used, but like all these cloud providers, they are having their own technical stack, providing something similar or even better. So we're just the tech space is exploding. There's a lot of new things happening every day, new problems enabled, new technologies emerging. I think it's there's a lot of opportunities. Especially I'm seeing the modernization of infrastructure for people doing like how to do SQL, how to do machine learning. It's getting modernizationing very fast currently. And so if there is a a lot of change, that means it's opportunity for you. Like everyone is new to this, right? So if you, for example, if you attend any, join a open source community, or there, by the way, most of this today, they will show as one of sort of like open source projects, at least as the beginning. Well, you can join the open source community, you can join a lot of different competition, like the Gaggle, all these contests. And there's a lot of tutorials outside there. And there's a lot of also training programs, paid or unpaid, you can find online. So I just feel like there's as long as you want to spend some time to improve yourself, and there's just different ways you can find something interesting to you to join it. And after, like, for example, once you started to do something, stay there for 1 or 2 years and just to know more people, join more different events, attending different events, knowing more people, you will find opportunities, right? Or you start from some junior job and then you just go more and more experienced. And during this process, you will find the opportunities are there. So yeah, I think like it's a very, to summarize, I think it's a very exciting time right now that all opportunities are emerging. So you should just like try to grab these opportunities by improving yourself.
Yeah, thank you for your comments there. So yesterday we have a speaker from Amazon. He's also my older friend, Andrew Chang. He used to work with IBM for many years, and also he was our speaker the year before last year. So he mentioned yesterday that 10 years ago, Hadoop, became popular as a big data, platform, and then we get into an age from big data to cloud big data. Everything to cloud, but now it seems like we have a new trend that the hybrid cloud means public cloud computing and also private. So my question is for Alluxio, as I know at the very beginning when I invited the CEO from Alluxio talk about big data, the topic is on Spark system, Alluxio is trying to build a shared file system. Okay, that's many years ago in our first, conference in, I think, 2016. But several years later, my understanding is Alluxio is moving to more analytics, right? Or something like, distributed, analytics, including machine learning, everything. Today you talk about deep learning. So can you tell us a little bit about, the trend, the big data analytics, the technology trend, what is your point? What is your feeling, what it will go? What is the direction it will go?
Yeah, that's a good question. That's very interesting. I just want to share a little bit more history about our project itself. As I mentioned in the slides, it was originated from the UC Berkeley AMP lab, where Spark is also born. There is Spark is also invented there. Also, like Apache Mesos is also invented there. So in the early days, actually, Alluxio, at that time, the research name is called Tachyon, was a part of Spark. It's a part of Spark that when people want to share the RDDs, want to persist the RDDs, they use the Tachyon inside. And later on, we built this into a more general purpose distributed system, not only work for Spark, but also for like MapReduce or some other systems. So that was like 2 to 3 years later, we expand the scope from Spark only to other systems to make it more general purpose. And then people realize, oh, not only in the analytics world, also other workloads like what I presented today, machine learning, deep learning workloads, they also see this. And also, especially in the Kubernetes environment, there's a strong need for such a caching layer for the distributed learning. So we expand the scope again, like from the analytics world to machine learning and AI workloads in the Kubernetes environment. And we're still like in the between storage and compute, but we're just facing more different components. And during this process, we definitely observe a strong trend. People are moving to cloud. People are moving from the on-premise data warehouse in the pure Hadoop environment to a single cloud. People are just running everything. They rent like a bare metal, like running Hadoop in the bare metals rented from the Hadoop from the cloud, or it's a multi-cloud or a hybrid cloud model. So this is definitely happening, especially like 2 to 3 years ago. I see a strong, like suddenly in 6 months, 6 months before, I think that's around 2018, maybe around that time frame. There's a very interesting 6-month period of time. Like before that, I see most of the people talking to me, they're still running. Their problems are in the single on-demand data. It's a single on-premise data warehouse, their own data centers. Like 6 months after, everyone is talking about, I'm running this in the cloud, or I'm running part of my jobs in the cloud. I'm investigating the path to migrate my jobs to the cloud. It's just like I would say it's a trend, and this trend will continue, at least in my mind, for at least another 5 years. Most of the people, most of workloads eventually will just run their work in the cloud environment. So then it opens a lot of interesting questions. In the cloud, a lot of things are designed originally not for the cloud. So if you just run Hadoop, all these things, they have some basic assumption, which is not really true anymore in the cloud. So people are still reinventing, some cloud providers change a little bit, to make it run faster or cheaper, but it's eventually like people will think about, let's sit down and see, how do we really create this infrastructure, big data infrastructure natively for the cloud. I think it's happening. There's a lot of latest discussion on how to build cloud native applications, cloud native infrastructure. So it's so I always say like this is something will keep going on for the next few years, for a decade, I would say.
Okay, yeah, thank you for your comments there. So my last question is, I think yesterday someone asked the same question from our attendees. Data science, data scientists, is such an amazing job. It changed a lot of, the business work from small companies, small startup company to large company like Facebook, LinkedIn, Amazon. But currently, the data scientist job not only about data analytics, machine learning, deep learning. I see a lot of people, the trend is, for the data scientists, they need the knowledge about big data, the distributed, computation, and also for the data engineers, they are working on Amazon, cloud, IBM cloud, Google cloud, Azure, from Microsoft and Alluxio. So, but the trend is they also need to know the data science, the data analytics, machine learning things. It's kind of a mix. The trend is, there's no clear border between this, two type of jobs. So I think you are focusing on, the distributed computation things, PhD, degree. So what do you think about, the big data engineers, the distributed computation? What is your thought about, how we can, leverage the distributed computation for a data science job, for the data analytics?
Well, I think there is a different dimensions to think about this. So, so if you think the data science as the one end of the spectrum, and distributed systems engineers, or people call them backend engineers, infrastructure engineers, another end of the spectrum. My background comes from the more on the very hardcore distributed systems, like I build a distributed system. I created algorithms for distributed systems. That's my background is coming from. I would say like right now, if you're just focusing on your own, like I'm just building my distributed systems, I'm building another file system, I'm building another query engine, I'm building another TensorFlow, it's perhaps still overlapping very little with data science as a junior engineer. But I would say like, or if you say, I'm just focusing on this is gonna be my specialty for the next 20 years, it's fine. It's very great, and in my mind, it's still very exciting. A lot of engineering challenges. It's a very exciting place to be. But I would say like because I'm wearing multiple hats, I'm working in a startup, so everyone is wearing multiple hats in a startup. So I'm also working on the community side. I'm engaging with the community, and I need to do a lot of things data-driven. So basically, I need to analyze data from day to day. I need to go and download the Google Analytics data. I need to go to download a lot of some metrics data for the community, and I need to analyze all this. And I'm learning how to use different data scientists tools to visualize this, to provide some insights, and especially to build dashboarding to the leadership of the company, to the board, to everyone like who wants to get insights. So I would say like once you either goes one level above to like facing a different set of problems, or to talking to a different set of people, then you start to realize how important being able to analyze data, being able to process data and dashboard data is important to you. It's actually like I know a lot of people, they start as a pure like hardcore engineer, infrastructure engineer, my family members or my friends, close friends. But once they move one step up, going to be more like a PM role or manager role, and they need to think about problems, they need to think about the business value for these projects, then they are learning, and actually they are doing a lot of data science work by themselves. Sometimes maybe they are collaborating with their other in-house data scientists. Sometimes they're just doing this by learning this. So I think like in the future, as someone going deeper in his or her career path, having the skill like this is definitely very important.
Okay. Yeah, thank you for your sharing. So I think we are running out of the time. And again, thank you being fun to join us as our, speaker. And thank you for your support. So many years, support the ID community.
It's my pleasure. It's my pleasure, Jason. And thank you for having your time here to listen to my talk. And this is my pleasure. Feel free to reach me out if you have further questions on Slack, on Alluxio, and I'm always on Alluxio Slack.
Okay.
Cool. Thank you.